All right, we're live. Hi
Hello.
there.
How's it going?
Hey, all good here. How are you, Connor?
Doing fine, doing fine.
Very exciting. Thank you. No, thank you very much for doing this with me, folks. If you're watching live, we're gonna be checking out some new stuff. Trying out Ruby with Wazi and Wasmtime and start like laying the groundwork to be able to integrate Ruby into the suborbital ecosystem. I hope I got that right, Connor.
Absolutely.
Fantastic. So to give a little bit of background, if I may, I'm just gonna um, share my screen real quick and sort of show some links and yeah. Um, here we go. Share screen. Yeah, and just sort of give some background as to what's going on here. So I should be sharing my screen now. I'm just gonna make it a little bigger. Yeah. So this is so. Why don't you, if you don't mind, Connor, telling us about this post you found and how it got started there.
Yeah, so a couple of days ago, I guess it was actually about 2 weeks ago, Richard posted this on Wasm Builders. And for anybody who's not familiar, Wasm Builders is a community site that we helped launch along with a number of other companies interested in WebAssembly. And it is a website based on Forum, which is the platform that powers dev.to. We worked with those lovely folks to get this all set up so that anybody interested in WebAssembly can come in, show off what they're working on, learn from other people, and just do a bunch of wonderful stuff together with the community. And when this post got submitted, it piqued my interest because I knew we were going to be doing this stream. So I made sure to bookmark it so that we could come back to it. And I wanted to point it out because this is the kind of thing that Wasm Builders was created for, helping other people in the community learn. So, Ramón and I today are going to use some of the resources in this post to start experimenting with Ruby.
Fantastic. Yeah, thank you. No, I'm so I mean, if I may add some personal background there, I Ruby was one of the first programming languages I learned. So it was pretty exciting for me to hear that it was getting integrated into WebAssembly, into sort of my into like what I'm doing nowadays. So when you volunteered, Connor, or when you were eager to try this out with me, I was very humbly grateful for that.
Yeah.
So yeah, I'd love to know, what do you recommend for getting started?
Well, I think Richard's post lays it out pretty well. I think the link in step 1 there, the Ruby Wasm releases page, I would suggest jumping over to that. It's got a lot of the work kind of done for us because
Fantastic.
the wonderful humans of the Ruby team have put together some tools and some steps for us. And if you just go to the root of that repository, the ruby.wasm repository, there are some instructions in the README.
Great. So and we can, oh wow. So there
Yeah.
are npm packages for this?
Yeah, there's NPM packages. They've got JavaScript host versions. They've got a WASI version, and we can talk about the difference if you think that would be useful. And yeah, a lot
Oh,
of
it would
this has
definitely
been
be
done.
helpful for me.
Yeah,
Because I think I understand the difference between what say WASI and mscripton, right? Mscripton is kind of like more geared towards the browser.
exactly. Yeah. So when we talk about WebAssembly, it kind of has two flavors, and sometimes they're referred to as WASM32 and WASM-WASI. They are designed to run in slightly different hosted environments. So the WASM32 version, which is, call it WebAssembly, classic, if you will, it
Mm-hmm.
was the version of the WebAssembly environment mainly designed to run in the browser, and which is why when you hear about a JavaScript host, this is usually what we mean by WebAssembly in the browser, because it was designed to be embedded into a JavaScript environment like V8. It was designed to be called using JavaScript APIs, and there are a
Gotcha.
number of JavaScript libraries and whatnot that you can use to very easily run WebAssembly in the browser. And then when we talk about the WASI environment, WASI stands for WebAssembly System Interface.
Yeah.
It is something for extra browser fun, if you will. It's designed to run outside of the browser.
Yeah.
And this is most commonly associated with running WebAssembly on the server, but it could very easily translate as well to things like IoT and command line applications and stuff like that. And that's what I think we're going to focus on, just because suborbital is a WASI environment. And so if we want to get Ruby running in Reactor and therefore Atmo, etc., we probably want to focus on the WASI version.
That's super exciting. That's something I'd love to try. So the best thing to do, how to package. So I guess the best thing to do is to try this out, right?
Let's do it.
Let me real quick, if I may. I'm just gonna reshare my screen so we also have a terminal.
Yeah.
And then I'll get that nice and easy.
Yeah, and I think it's worth talking about the two dependencies that they list there on that page once you've got your screen back up.
Sure thing.
Because we need two tools. One is called WASI VFS and the other is called Wasmtime. And these are the WASI VFS. That is hard to say. Is actually something relatively new to me. I only played with it for the first time like last week or 2 weeks ago. But it is a very interesting tool that can make WebAssembly a little bit more familiar to programming languages that rely on a file system, which for a scripting and script-like languages, that's pretty important, being able to pull the source files off of a file system. But what WASI VFS does is it creates a virtual file system inside of a WebAssembly module. So it's not a real file system. It's not actually talking to like the disk on your computer, but it has the system APIs that are needed to emulate a file system, so that when something like Ruby needs to read, the Ruby script or some supporting file, it can do that without completely changing the way that, the Ruby interpreter works.
Cool.
And then Wasmtime is a WebAssembly runtime. So it is something that runs outside of the browser, as we talked about, and it allows us to execute WebAssembly binaries just on the command line or on the server or wherever we need it, outside of the browser.
Awesome. So yeah, I'll be downloading this pre-built Ruby police extract. Okay. So I will need to install WASI VFS and Wasmtime. I think I have Wasmtime installed, but I guess I can double check that. And this is what you mentioned, where we're having a virtual file system inside our WebAssembly module.
Exactly. So yeah, WASI VFS, it kind of helps package things up together so that they work more seamlessly.
But this is for Linux. I'm on
Yeah.
Mac OS.
So if you pop up to the releases page near the top, there is and you just click on that latest release, there should be a Darwin version.
Cool.
I'm assuming you're on M1?
Yeah.
Yeah. So AAR64 is what you want.
Perfect. And then I can go over to nope, wrong terminal. Yes. And I can open that. Keep that. Sorry. There we go. So I've extracted that now. This is not terribly interesting. Sorry about that. The dangers of having a full screen. Where was I? So I've got this WASI. Sorry, give me 1 sec, and I'll get that up and running.
Yeah, hopefully it should just be a command line binary that you can put into, user local bin or something like that and
Perfect.
get it ready to go.
Yep, I've got it here. So I can, let me just make this a little bit bigger. So that'll be WasmVFS. That is indeed binary user local bin. Of course, I need to sudo do that. But I still need to make it executable, right? With chmod, I think.
It might work just on its own.
Looks like it. Apple's already unhappy.
Yeah. So we can work around that. That's a pretty common thing. I'm not even sure if I want to share this hack because you should not do this for most things. But because I know the authors of this and I trust them, I'll go ahead and say it's all right. If you open System Preferences for your Mac and you go to the Security section, there is a way to allow these binaries.
Yeah. How do I
usually just spotlight, command spacebar and search for security.
Oh yeah, there we go.
Yeah.
System preferences and where? Sorry, was it security?
Yeah, the security and privacy and the top row. Top section, bottom row. There you go.
Perfect.
And then you can go to General, I believe, the top tab, and
yeah.
allow anyways. Yeah, just click that button, and then when you go back and you execute that again, it should do so without complaint.
Perfect. Cannot be opened, but now I can open it. Yeah, there we go.
There you go. Yeah.
Fantastic. So that's
just tell an Apple that you trust it.
Yeah, gotcha. Yeah, this brings back good memories of my macOS developer days of code signing and all that.
Oh yes.
So I think I've got this installed. Can I check it? Wasmtime. Yeah. So now I'm installing Wasmtime, which I do not, in fact, have installed. But I can do that here with this command. And I'm getting an error that it only provides pre-built binaries for x86/64 architectures. And if I remember, there's a way to change ZSH to allow me to.
I do believe that Wasmtime has new. Let me see. Oh, yeah, you're right. They don't have an ARM64 version, do they?
Yeah.
Well,
Surprised I did this before, or maybe I never did. So
yeah, so all we need to do is there's an arch command.
Yeah, like that. Arch.
Oh, yeah, I'll just paste it into the private chat so that you can grab it.
Perfect.
And then you can.
I'll also put it in the chat so if in case folks are interested. If you're doing M1 stuff, this is what you want to run, and this will let you run in a, let's say, universal. What is it called? They call it Rosetta, I think.
Yeah, Rosetta, exactly.
So that would be, where am I? Oh yeah, I'm still in Wasmtime, which I do not have. So I'm gonna install Wasmtime again. Cool. So that's now done.
Perfect. So you should be able to theoretically run the Wasmtime executable now.
Which I can. No. Oh, open a new terminal. Can I actually do that from back in my
if you type exit, you'll go back out to your native one and then run that arch command again.
Oh yeah. Out of curiosity, would I be able to run it from my usual Arch architecture?
Possibly. If you remove the /bin/bash there and just type Wasmtime instead,
okay.
It's possible that will work. You probably do need to restart this terminal just to make sure it's installed everything.
So, and then out of curiosity, I'm just going to try if I could spell it correctly. That looks good.
There we go. Wonderful.
So that's good to know. So you can install Wasmtime by doing this Arch stuff, by
Yeah.
switching to an x86 60. Yeah.
Yep.
Cool. So that's both of them installed. And next we just got to download a pre-built Ruby release of ruby.wasm. Yeah, so I'll do that. So this is a built version of Ruby. I'm just going to go back to my open source. So this is a built version of Ruby that we're downloading from the internet that is pre-built towards the Wasm 32 architecture.
Yep.
Cool. So then I'm going to untar it. Extract the Ruby binary to not to pack itself.
I'm not sure what that means, but I think we're just
I'm not sure either.
pulling the specific file that we want out of there.
There it is. Yeah.
Cool. So now we want to create a Ruby script.
Yes. We're piping a print line statement into my underscore app.rd.
Mm-hmm.
Pack the whole directory under user into your app dir. So we're using WasmVFS to pack with Ruby Wasm our Ruby code into a virtual file system.
Exactly.
Interesting. So we're creating a WebAssembly module within which there is a not yet compiled Ruby script.
Exactly. Yeah. So we're taking ruby.wasm, which is essentially the Ruby interpreter, right? So when you install Ruby normally, you get the Ruby executable, which is the Ruby interpreter that reads in Ruby source code and interprets it and runs it. All they've really done, and I say really, but it is actually quite amazing. They've taken that same interpreter and they've just, instead of compiling it to, a Darwin or a Linux binary, they've instead compiled it to WebAssembly. And so now WasmVFS takes that ruby.wasm that we downloaded, which is the Ruby interpreter, and it packages in a bunch of files, which in this case is your, what did you call it? My app.rb, exactly.
Yeah.
And it creates that virtual file system. So you can see that we're mapping a couple of directories with the command line flags there, which are the files that Ruby needs to run your application. And so theoretically, the my Ruby app.wasm that got output should be a single WebAssembly module that includes the Ruby interpreter and your source code that you just created there. And if we use Wasmtime to execute this, when it starts up the WebAssembly module, it will load the Ruby interpreter. The Ruby interpreter will read our script off of the virtual file system and then execute it just like normal.
Wow. Okay. This isn't what I anticipated at all. So what we've got here is essentially we're running Wasmtime with my Ruby app, and am I understanding correctly? We're passing in a parameter here.
Yep, exactly.
Which is inside the file system, the Ruby script.
Yep. So you can see on when we ran WasmVFS, you'll see that we did mapdir/source to ./source.
That feels very Dockery.
A little bit, yeah. And so what this did was take the source folder on your laptop and put it into the WebAssembly module as a virtual /source.
Wow.
Yeah.
Okay. Cool.
So why don't we give it a try?
Yeah. So that's starting up, I assume.
Yeah.
It could be a little bit slow, I guess, because of my because of the different architecture and
so it worked. That's awesome.
It did work. That's incredible.
Yeah, and I expect that it took a few seconds there because we have to remember that it is starting up a Ruby interpreter and parsing, the code. It is executing an entire Ruby environment within that WebAssembly module. Now, this is something that we came across when we wanted to add JavaScript support to Suborbital. We realized, hey, there's a bit of a startup time here when you launch the WebAssembly module with a packaged JavaScript runtime, because fundamentally, this is a very similar strategy to how we run JavaScript inside of WebAssembly, which we can talk about how that works a little later.
Sure.
But when you start that module up, it is starting the Ruby interpreter. The Ruby interpreter is reading your script. It's parsing the script. It's doing, all the compilation that the Ruby interpreter usually does, and then it's executing it. So we came across a similar issue with JavaScript where it was taking a little bit of time at the beginning to, get started. And so what we did is we used a tool called Wiser, and I can grab a link to that for the folks in the chat.
Thank you. Yeah, we've got a comment here from Bruno saying this is awesome. Ruby apps packaged in one file and it's not Docker.
Yeah. So I sent you the link there. I think you'll need to put it into the public comments. But what Wiser does is allows us to pre-initialize a WebAssembly module. So it allows us to actually start up the module while we're building it, execute all the preamble. So the stuff that happens at the beginning, the parsing and the compiling of the code. And then once that initial setup phase is done, which as we just saw took a couple of seconds, we can then take a snapshot of the module state, and we can create a new WebAssembly module from that snapshot. So gotcha. For the suborbital JavaScript support, we're using a JavaScript runtime, which is called Quick.js, also compiled to WebAssembly, and we're also packaging in JavaScript source code into this single WebAssembly module. And we use Wiser, which is actually built into a project called Javi, which is something we've worked on with Shopify to help make running JavaScript inside of WebAssembly a little bit easier. So we automatically run Wiser on those modules so that the JavaScript engine starts up, reads the JavaScript, and parses it when we build the module, rather than when we want to execute the module. And this makes everything a lot faster, and it ensures that we can get those quick startup times that WebAssembly is known for.
Gotcha. This explains a lot. Thank you. Fascinating. So now we've got, I'm actually quite curious. How is it ls with an L that gives you the file sizes?
I believe so.
Yeah. So we've got here, actually I have no idea how much that is. Is that in bytes or bits?
I believe that's in bytes, so that's probably
23 megabytes.
Yeah. So the Ruby interpreter, right, it's not necessarily small. Now there are some additional tools that we can use to make WebAssembly modules smaller. I will try to find one here. I believe it's part of the Binarian project. So it's called Wasm Opt. And
Wasm Opt.
Let me find it here. Think.
Is it on NPM?
No, it's part of the Binarian project, which is another WebAssembly compiler. I'm just trying to. It's a sub package, so I need to find where inside of Binarian this exists. But yeah, the general idea with Wasm Opt is that we can run an optimization pass on the WebAssembly module, which can optimize the size of it. But I am not finding it off the top of my head, so I will post it on Twitter later when I find it.
Thank you. Cool. So we've got this Ruby Wasm, which is our interpreter. We're able to create apps with it with Wasm. We're able to create modules that we can run with Wasmtime, what comes next? So how do we start it? Yeah.
Yeah. So there are a number of things that are needed to run a WASI module within suborbital. And one of the things that we would need is a start function that is exported from the module. And the other thing that suborbital's runtime needs is the ability to allocate and deallocate blocks of memory.
Gotcha.
Now, these are not immediately available, as far as I can tell, in the Ruby release that we're working with here. I think it's something that they're working on.
Okay,
But
so it's
I
not
couldn't
something we could.
find.
Yeah.
Yeah, I couldn't find a way to do this when I was looking this up yesterday. And so moving forward, we're going to rely on the Ruby team to add the ability to export certain things from the WebAssembly module. Because right now, I mean, it's I would say it's a pretty basic implementation. It's incredibly impressive what they've been able to do, and the fact that they've put it into
Yeah.
mainline Ruby is just fantastic. It really shows how important WebAssembly is becoming. But there are WebAssembly features and tooling capabilities that we don't quite have yet, that we would need for full support. Now, that said, suborbital is based on Wasmtime, so we can absolutely execute the modules that we've created here.
Mhm.
But in order to get full support, we will need that ability to export functions from the module, because the suborbital runtime needs to call certain functions to efficiently run these serverless functions.
Gotcha.
So today we won't be able to add full support to suborbital. However, we can we've definitely shown here that Ruby in WebAssembly is a fully possible and capable way of running Ruby.
Totally. Which is super exciting.
Yeah, absolutely. I think there will be a day where running a Rails application inside of
Mhm.
WebAssembly will be perfectly feasible. It's going to take a lot of work on tooling, but there's no reason that can't happen someday.
Running Rails within a browser sounds really wild to me.
Yeah, browsers, servers, IoT, pretty much anything you want.
Yeah, amazing.
Yeah.
Cool. So to start laying that groundwork, so to speak, I guess I would need to start looking at the suborbital projects.
Yeah, so we can take a look at the API that we would need to have if you'd like.
Sure. By the way, Connor and I we talked about this beforehand. If like I'm happy to drive, but if you would like to also drive, like we can make this super smooth.
Yeah, sure. I can take a turn.
Sounds good. This is super. This already doing this was super exciting.
Yeah. Let's see here. I will share a window. Oh, or I'll share
Hopefully
my
you
entire screen.
hopefully you won't need to restart Chrome.
No, it's all
Something.
good.
Okay, I see here you're sharing. I'm gonna go ahead.
Yep.
Oh, sorry. Would you mind making this a little bit larger, please? The
Oh, yeah,
text.
for sure.
Thank you.
Yeah. So let's take a look at one of the other language implementations inside of Suborbital. So for a little bit of context, Reactor is our lowest level project. It is the what we call a WebAssembly Job Scheduler. So it allows us to take WebAssembly modules and execute a whole bunch of them concurrently together in a single environment. And this is kind of the part of Suborbital that powers our server framework Atmo, our edge compute server SAT, and allows us to really efficiently run a lot of WebAssembly modules all at once. And so within Reactor is where we see all of our language support. So if we take a peek at Rust, for example, and we pop in to the Rust crate that we have here, there are a whole bunch of different, definitions of the suborbital Rust API. So if we pop into like HTTP, for example, this is what a WebAssembly host to guest interoperability function looks like. So the WebAssembly module is able to call a function called fetchURL, which is then passed through the WebAssembly runtime to the host, which in this case is Reactor, and Reactor will make it happen. Reactor will actually make an HTTP call. So as you can see here, we're expecting an external function to be added to the WebAssembly runtime. And so that's part of Reactor's job, is to make these functions available to the WebAssembly modules so that they can access, we call them capabilities, but really what they are APIs. And there are a couple of, pretty essential, I guess, APIs that are absolutely needed to run WebAssembly modules within Reactor. In particular, we have this run function. So this is the function that the user, like the developer who's writing these WebAssembly modules, they write a run function in order to actually do some work. So every time the WebAssembly module is called, this run function is what gets called, that actually executes the developer's code. And then, do you have a question?
Yeah, sorry, I'm gonna be asking a bunch of questions if you don't mind.
Yeah.
So are this function run, which is a runnable trait,
Mhm.
is this related to the suborbital runnables?
Yeah, absolutely. So what we refer to as a runnable is a WebAssembly module that has these APIs exposed, essentially. So if we have a specification that says if you expose, these particular functions, then you are considered a runnable, and it is something that can execute within the suborbital runtime. So that's what we would need to
Gotcha.
do for Ruby if we wanted to make this work. So, exposing the run function is one. The other two that we need are allocate and deallocate. And this allows us
That
to,
was the memory.
that allows us to create and destroy memory within the WebAssembly modules. So when we are, for example, handling an HTTP request, we need to be able to write the data from the HTTP request into the WebAssembly module so that it can access, the details of the request. And so the host is able to call this allocate function on the module to create a block of memory that it can, write some data into. And then similarly, when we're done, we can deallocate that same memory.
Gotcha.
Yeah.
So we would need to write the series of these implementations of these traits.
Exactly.
Well, traits or interfaces. Yeah.
Yeah. In Rust, they're called traits. In Go, they're called interfaces. It's depends on the language, but yeah, we do need to have run and allocate and deallocate. And then there's a bunch of optional ones, right? So there's the HTTP capabilities. There's the all of what we have here: accessing caches, accessing databases, accessing files, GraphQL, HTTP, logging, handling requests and responses. Like, all of these things are optional. Really, all we need 100% is those three, run, allocate, and deallocate. But there's also a bunch of optional ones that can give the developer access to a whole bunch of APIs to, build more useful applications.
So in theory, if I wanted to add my own language, I guess I could contribute my own, and there's a certain API. There's a set of this set of APIs. Is it documented somewhere?
So we have we have what we call a WIT interface.
Interesting.
So this is kind of a declarative definition of what the interface of what the API looks like. So you can see the definition of all the different functions here. This is still in PR because WitBindGen, which is the project that uses WIT files, is still pretty rapidly evolving. And so, it's not quite done yet. And so we're still evolving our WIT specification. But
Gotcha.
yeah, there are ways to, document and create your own versions of this.
Fascinating. Cool. So we'd be essentially starting to add these, to be adding these for Ruby.
Exactly.
Awesome.
Yeah.
I'm super excited. Do we need to integrate Ruby Wasm somehow, or?
So ruby.wasm I don't think would change.
Yeah.
The interpreter will always be the same. It's a matter of the code that gets bundled in with ruby.wasm needs to be able to export and import functions.
Right. Which is
which, as far as I can tell, I haven't found any documentation on it yet. It's entirely possible that I just couldn't find it, or that it's not yet documented, because this is, let's remind ourselves, still a preview, right? The release is not fully out yet.
Out of curiosity, sorry.
Go ahead.
Is memory management? Can I call it memory management?
Mm-hmm.
And function exporting part of WASI?
So yeah, memory and functions, these are WebAssembly primitives. So if we, I'm trying to think of the best, what would be the best way of showing this? Yeah, I guess the core specification. So we have somewhere in here, theoretically, there is, that's the text value. Somewhere in the specification, it does talk about.
So it's like a, because if I understood correctly, WASI is kind of like built on top of WebAssembly as a standard.
Yeah, WASI is a set of APIs that are defined for WebAssembly. This is not. I would probably point to the GitHub repo. Oh, I guess that's where this redirects to. Yeah, the definition of what memory is, what functions are.
Flaky says it might be structure.
Structure.
Where did I see that? Oh yeah, under structure. Yeah.
Yeah, it could be under modules.
Sorry, would you mind making it larger again, please?
Mm-hmm. Yeah, you can see here that we've got a module can consist of a bunch of different things. So we've got things like a memory, and a memory is, a linear group of bytes that act as the virtual memory for a module. We've got functions. So functions can be either exported from the module so that they can be accessed from the host, or they can be imported from the host so that they're available in the module.
Gotcha.
Yeah.
Cool. So what we could start doing today then, if I understood correctly, was starting to very, very slowly add some of these APIs for, some of these, add some of these API implementations for Ruby that don't need functions or memory management, which I hope isn't all of them, or do you think they are?
Yeah, I don't think that we will be able to get things running today.
Yeah.
It's the ability to create and export is definitely required.
Yeah.
And it's not something we can do yet, unfortunately.
Okay. So there's what kind of let's say background could we settle for it?
Well,
if any.
Yeah, I don't know if there is anything for right now. I think we should probably revisit this when the Ruby release is finalized, because I fully expect that they will add more documentation and potentially more, APIs and capabilities, because that will be, what we need.
Yeah, this is coming with Ruby 3.2,
Mhm.
which had this preview released in early April. I actually don't know how often they come out.
I'm not sure.
3.1.2 was released last week. Yeah, I guess we just gotta give it some time and see what happens. This has been super fascinating though, and helps me really understand better how we can start to do this. So in theory, this is something you said that they were working on it.
As far as I understand, yes. The
'Cause I didn't-
ability, the ability to export things, it's not the simplest thing, and
Yeah.
I think they need to approach that carefully, just to make sure that it is something that is, compatible with the Ruby way of doing things. Every language handles it differently,
Yeah.
so I think they just need to make sure that they're doing it in a way that would be familiar to Ruby developers.
Right. So, and once we have that sort of green light, then we could in theory integrate that into Reactor, which would then, if I'm not mistaken, cascade into the rest of the suborbital ecosystem.
Exactly.
Like we'd need to add. I was actually taking a look at the Subo source code lately with one of our colleagues, Jagger, and so I saw that there's. So I guess one thing we would need to do, for example, is add a sample runnable template
Yeah.
there.
Yeah. So as part of our CLI, like you said, that there are templates for the different languages that we support, and that would be definitely one of the steps. It's actually not required. You can run a WebAssembly module in Reactor as long as it conforms to that Runnable specification.
Yeah.
But in order to make things easier for people using suborbital, we do create these templates that can be it's used by the subo create runnable command to just very easily bootstrap a new function in any of the languages we support.
Awesome. Yeah, actually, not to take us too far off topic, but one thing that I started looking into, because I saw that for runnables we had the ability to specify a Git repo,
Mhm.
so that folks could make their own templates.
Yep, absolutely.
And then the thought kind of came around, is like, let's leverage that and make one for Atmo projects as well, which envelop a collection of runnables and help manage that. That's probably a very butchered way of saying it, but that's the mental mapping I have. I hope
Yeah,
that's
So
possible.
we actually have a template here for a new project, and it comes with the directive file. You can see these are all templated values.
Yeah.
But when you run subo create project, it does in fact use this template to create your brand new Atmo project.
Fantastic. Yeah, so it sounds to me like we gotta give it some time until they've got this release at least ready to, what do they call it, a release candidate ready, and then we can start take another look at it, right?
Yeah, I think we should definitely do a part 2.
Yeah, sounds great. Well, hey Connor, this has been great, super chill, and I learned a lot, so thank you very much.
Yeah, my pleasure. Glad we got to do it.
Yeah, and to folks watching, stay tuned. We're gonna do this again soon, hopefully, and yeah, we'll see about integrate. I like Ruby a lot.
Yeah.
So I'm excited to look into that. Well, thanks a lot, everybody, and as Flocky says, living on the bleeding edge. Yeah, thanks you so much, and see you next time. Take care,
We're
everyone.
on. Bye.